Due to very high popular demand, we have now added Subway Surfers. Great. Let's check out the differences between a population and a sample. What is a population? As we previously discussed, it's the entire abstract set of individuals or objects that the study is trying to look at. Whereas the sample is a targeted subset selected for the actual study. Now, because we cannot access all of humanity at once, which is our population, for example, we use a sample of that population to make inferences from. And the way we pick these samples, there are multiple different methods. When we look at the quantitative methods, we have probability sampling. The simplest of them is simple random sampling, which is abbreviated to SRS. What does this mean? You assign a number to 500 employees and then pick 50 at random. There's no rhyme or reason to it. You just get 50 people without thinking about it at all. Now, a more organized version of SRS is systematic sampling. We were simply randomly selecting, now we are systematically sampling. What is it? You, for example, start from the fifth person and then pick every 10th person that's after that. For example, you start from the, what is it? You start from the fifth person and then you choose the 15th person and then you choose the 25th person and then you choose the 35th and then at the end you have 4 participants that you've selected for your study. Now, this can introduce some issues like causing bias. For example, if the list has a hidden pattern like alternating genders, this may cause only females to be selected, for example. But it's simply just picking every nth person, kth person, speaking mathematically. It's simple, really. Instead of picking at random, you pick at an interval. There's also stratified sampling. It's more for heterogeneous populations. What is heterogeneous populations? It's populations that are diversified, so they're not homogeneous. So you divide them into subgroups, which we call strata, based on a characteristic. For example, you want to make a study on staff within a hospital. Okay? So you divide people based on their profession: nurses, doctors, supply people, etc. And then you pick random samples proportionally from each. For example, in this example, they are looking at the population of a city and they are picking 20% elderly, 50% middle aged, and 30% youth. And we will have a sample of 100 total people. So we will pick 20 elderly people, 50 middle aged people, and 30 young people, maybe babies, I'm not sure. Now, a similar but different one is cluster sampling. It's more commonly used for wide geographic areas, and you randomly select naturally occurring clusters like schools, cities, rather than individuals. Okay? So, for example, you want to study teachers in Turkey, you randomly select 10 cities, you select 5 schools per city, and survey individuals within those schools. To sum it up, simple random sampling. Just whoever comes to your mind, everyone has an equal chance of being selected. Systematic sampling, a more sophisticated version of simple random sampling, which is picking every 10th person, for example. Stratified sampling is categorizing people, putting them into strata, and then picking a percentage from the total samples that you want to get. Cluster sampling, as we discussed, is picking from naturally occurring subsets, clusters, whatever. Now, when we are moving to qualitative, it's a bit more different. We have purposeful sampling, which relies on people's qualities. In qualitative research, statistical generalization is not the goal. Instead, researchers use purposeful sampling to select information rich cases that provide contextual depth and deep understanding. It's like you are creating case studies. So, extreme/defined case sampling is the first method that we can use. It focuses on highly unusual situations outside dominant patterns. So these are not things that you would encounter in your day to day life. As we said, like doing a case study on someone with an incredibly rare disease. A critical case sampling examines a single event with sweeping systemic implications to ask if it happens here, will it happen everywhere? For example, you investigate nationwide protests following the police killing of an immigrant child in France to understand potential vulnerabilities in Turkey. This is critical case. So, something happened somewhere, will it happen somewhere else? Typical case is just finding out the most Jonathan of a group, the most standard of activities, sleeping, and you try to inform the public based on those. You don't try to generalize it because there's really nothing to generalize. The topic is just so simple. So you just do a deep dive on that subject to gain some more information on it. It focuses on standard practices to inform the public, like assessing the adequacy of online education practices and developing students' professional skills. We have group dynamics, which is we can do homogeneous sampling, which focuses on the similarity to identify shared problems and solutions, like running focus groups strictly composed of working in journalists to isolate their specific personal professional problems. You take a homogeneous subset of people, whereas in heterogeneous sampling, it focuses on diversity to analyze relationships and points of divergence. For example, studying the adaptation problems of refugee children in primary schools by selecting students from the widest possible variety of countries. You try to see the common problems and what differs. When you look at network and theory, we can see snowball sampling. For example, you're trying to investigate a drug ring. You cannot really open your research up and say, look, we're doing a research on drug addicts. Would you like to come join it? Nobody's going to come because it's illegal. So, what you do is you find one person, and that one person refers you to their friends. Theoretical sampling is the sample selection is dictated purely by the need to develop a theory. The researcher stops gathering data at the saturation point, which occurs when new concepts stop emerging and data begins to repeat itself. So, this is used when you are just trying to construct a new theory. Convenience sampling is basically the laziest form of sampling. You just stand outside a library and ask whoever walks by to fill out a survey, which carries a high risk of bias, of course. It's the easiest and the lowest cost, but of course, it comes with its disadvantages. Now, to execute probability sampling effectively, the researcher must identify a sampling frame, which is the concrete list containing all the units in the conceptual target population. Now, if there is a mismatch between the abstract target population and the concrete sampling frame, it leads to biased samples. These don't make sense, so let's look at the examples. In the Turkey 2023 general elections, opinion polls failed to match actual results because their sampling frames systematically excluded overseas voters and newly registered individuals. So their samples did not contain any of these people. Therefore, their research was not really explanatory for actuality. What this means is when you're picking your samples, make sure they actually represent the population. Because if they don't, you're gonna get wrong information. It's as simple as that. Now, there are some sizing heuristics that we have, which defines that if you want your research to be more confident, you gotta pick more samples, which is just a 2 plus 2 equals 4. And there's something we call the growth curve, which says smaller populations require a larger sampling ratio. However, as population grow massive, the required sample size stabilizes, allowing for smaller yet reliable sampling ratios. The reason this happens is because when you have so diverse of a population, when you have so many members of a population, simply when you pick samples of that population, the statistical, I guess, probability that the samples you've picked are diverse are higher. So they are more indicative of the population. It goes both ways. Because there are so many people, whatever you find out in your samples is bound to apply to some percentage of the population. It's a bit of a statistical anomaly, really. It's an oversight. If we look at the subgroup quota, if a researcher intends to analyze and compare multiple subgroups, for example, gender, income levels, departments, the overall sample must be large enough so that each distinct subgroup contains at least 50 cases. Well, 50 is a nice number, I guess. That's why they used it. I'm not really sure why 50, but they say if you are looking at subsets of people, if you've classified them into strata, then you need 50 people from each distinct subgroup. And that was it for week 7. To go over it quickly, we have SRS, systematic sampling, stratified sampling, cluster sampling. And for qualitative, we have extreme case sampling, critical case sampling, typical case sampling, homogeneous, heterogeneous, snowball, theoretical, and convenience sampling. Since it's an MCQ, you don't need to really memorize any of this. Just know, because these are so similar to each other in their names, systematic sampling is similar to the simple random sampling, and stratified sampling is just working with percentages. You make a strategy to divide that percentage. Yeah, sure. Whereas in systematic sampling, you have a set system, almost a formula to divide that population into samples. I hope it's explanatory.